Good evening, everybody, or hi, I don't know if it's even where you are. And I'd like to thank you that you've joined us for this very special webinar. Our title today is Creating an Unbreakable Chain of Custody within CI/CD Pipelines, but a little bit more about that in a second. Today is also special because it's the very first time that my guest is actually in the same room with me, which is, it's a bit weird. I'm used to watching them across the screen.
You see?
Hey, in the same room. I have with me here Angel Rivera, the principal developer advocate for Circle CI. Angel, thank you so much for joining me today.
You're welcome. Thank you for having me. It's an honor.
Gladly. And yeah, we're going to talk about pipelines today. Circle CI was a good candidate because, hey, that's what they do, pipelines.
That's all we do, yeah. Good at it.
Just because I want to make sure that, as usual, we start on even footing. Angel, because, like you said, that's what you do and you're good at it. Why don't you tell us, what's a pipeline? What's a CI/CD pipeline?
Oh, yeah. So I'm going to give you a little history lesson for those folks that maybe give a little foundation. I'm pretty big on that. So previous to, let's talk about previous to continuous integration, this concept of where we're constantly integrating our changes into code bases, right? So it's more of a, before this continuous integration concept came about. We were working in kind of a structured and more serialized kind of manner where developers were not really communicating or collaborating outside of the code base. And that was causing blockages, right? Like, so code would take, back in the day, I don't know if you remember when, you would get a update to some operating system, we won't name who, but it would be like every year, right? You would get a new CD or something. Those are releases, right, for new software. Fast forward to the age of continuous integration, the software developers and release managers got smarter and said, hey, this is not efficient. And continuous integration, again, is one of those concepts, right, that enables teams to collaborate around software and changes more specifically, and then implement them in their workflows, right? So meaning the teams now have a more efficient way of producing these changes and a more collaborative way of verifying that these changes are legit, so to speak, right? So again, that's a conceptual, quick CI definition. And what Circle CI does is basically automates those practices, right, through what we call pipelines, definitions, right? So imagine you have this manual process like testing code, maybe running some security scans, maybe running or building artifacts, right, to be deployed. A lot of times, before this concept was introduced and Circle CI and other tools existed, it was a manual thing that occurred in the developer's environment, which also created other downstream problems like, hey, this worked on your laptop, but it doesn't work on the server. But what we've done is basically built a platform that enables pretty much anybody who's involved in the release process to build automation around the things and the tasks that need to be accomplished, so that what it boils down to is a developer or someone creating changes to a project or code. All they have to do is do a commit, git commit into the version control system, and then do a push upstream. And once that code is detected by Circle CI as changed, the upstream push will make that the modification. Then we kick off that automated pipeline, which means we'll run the things that are defined in it, right? Which will lead us into our conversation today around how to build some chain of custody within your pipeline. Understand?
But before that, I just want to mention again, just like we said in our brief before, describing this webinar, we're going to be using some specific examples of tools and particular pipelines like GitHub or Circle CI, but this conversation is true for everybody. It doesn't matter which pipeline you're using or which SCM. But we're going to be talking a lot about principles and the things that people should pay attention to within their pipeline, however they're defining it. And we're just going to use the tools as examples just because these are the tools we know. But assuming you find something that is of interest to you, you should definitely check whatever tools fit you and your pipeline, and however it is you do your work. Now, the second point I'd like to make, just because some people have commented to me that the title of unbreakable chain of custody could be construed as a bit overpowering, maybe. We're going to give you some very good advice about some various potential failure points within your pipeline. I don't know if unbreakable is the right word, just because I don't know how you define your pipeline or what tools and processes you're using. So definitely implementing some of our advice would make your pipeline more secure, better, give you better insight into what's happening in it. Whether or not you can call it unbreakable chain of custody is up to your interpretation. We'll definitely do our best to impart some important information. Now, having said that, now that we know that essentially a pipeline is, putting it concisely, as a list of instructions that is being carried out automatically with the purpose or intent of turning raw code into a product in a continuous manner, speeding up the generation of software processes everywhere. Let's take a look at the generic pipeline and start talking about it. We've prepared in advance a nice little slide demonstrating a generic pipeline, very, very generic, not even, no pipeline specifically, just some processes or elements that we knew go into a pipeline that we wanted to talk about. So at the left side, Now you can see where the shift left probably term came from. On the left side, we have the developer. He works on code. He uploads it. Great. Now we want to start that automating process, and probably the first thing that is going to happen is that the pipeline is going to check the pipeline definition. That file that is the list of instructions. Usually it goes in a YAML file, sometimes other things, but a YAML config is usually the common concept for this. After that, the pipeline would check out your source code, whatever it is, in whatever language. It will be pulling some secrets. It will be defining the cache, which means the dependencies or any other tools or elements necessary to compile the code. It would then do various tests, some integration tests, some tests on the ability of the new code to integrate with the old one, unit tests, whatever tests you need. Sometimes security scans like dynamic testing or static code scanning, whatever you need. After that, you finally build something. You build a binary, you build an image, and after everything is built, you're ready for deployment. And that thing, all of it happens continuously and automatically. Every time some developer uploads something to that pipeline, all of this will happen again and again and again and again. All of it automatic. Eventually, you'll get that deployment happening almost by magic every time there's a new update. But here's the thing about magic. Until you look behind the curtain, a lot of bad stuff could be happening there. What we wrote in our brief is that a lot of times those pipelines, other than the YAML file or the instructions that you've implemented, it's kind of opaque. You don't really know what's happening there. So, Angel, now that we have that image in front of us, the first topic that we thought about discussing when we talked about this webinar was secret management. Why don't you tell us about that? What are those secrets and why should people manage them?
So just like any environment, right, that you're running code or software on, in today's world, we do a lot of integrations with other services, other software, right, where we're accessing databases, we're accessing cloud providers, right? All these things require a access, right? Or in the form of a token, in the form of an API key, whatever, right? But at the end of the day, all of these things that we use to connect to other services, like passwords, tokens, API keys, we'll just call them secrets because they need to be maintained as sensitive, right? They're sensitive data, so they need to be maintained. So we'll just use the generic term secrets to manage that, right? So again, secrets come in many flavors, which I already kind of went through twice. I'm not going to do it again. But at the end of the day, when you're talking about automation, right, the automation itself needs to have access to this information, these secrets, in order to go ahead and connect to things and maybe kick off a workload on another system, right? Or do a query against a database or an API. So that when we're talking about secrets in a pipeline, one of the things that if we're looking at let's just take a look at our example here. Maybe we're going to do a testing, right? We're going to test and we're going to use maybe a tool like Cypress, which is one of the nice ones that they use for services and that they use for front-end kind of testing. You're going to need some sort of access to Cypress, right, to run against. So what happens in pipelines is generally, and this happens in all continuous integration, Service UI and others, we have a system where you actually would obviously assign what we call a context environment variable for your project, and that's what essentially is you define just like any environment variable, you define a name and then a value for that, right? The difference is that when you declare that in our system, it gets recorded, saved, encrypted at rest, and then in flight it's also encrypted when it's introduced. So like when your pipeline kicks off, and let's say actually when you're doing a checkout for GitHub, let's say version control system, you probably have an account, you have an identity, and that has maybe an SSH key tied to it, right? So you would be able to then maybe define that as a secret, and then when the system needs to get your code, it's going to authenticate using that information that's predefined. So the problem with all of this is if you have a static secret that's there, right, you don't have any type of rotational policies, right? It's always good to kind of switch out your tokens and your access
information.
Information as often as possible, right? So you want to shorten that attack vector, potentially potential exploitation vector, right, for that. So if those things get exposed, then if your tokens only last for 30 minutes, right, then your attack exposure attack window is 30 minutes, right? So with secrets management, there's tools out there that people can integrate into their pipelines. One of them that I like to kind of talk about is HashiCorp Vault. It's pretty easy to set up, and the documentation is really, really good. And I've actually had hands-on experience with it. So one of the things that you could do in your outside of the pipeline is create this Vault experience or infrastructure, and then manage the policies around the tokens, and then integrate that into maybe an API call, because Circle CI, for example, has APIs that you could actually connect and your secrets management system to. Maybe you can even script this out in Python, which is what I've done, and have a cron job that runs every 30 seconds and then rotate keys out, right? As long as you're doing it on both ends, obviously, right? So that's one example of a secrets management implementation that you could leverage, and again, make things a little bit more secure when we're talking about secrets management, right?
I would like to just to make things clear, to give an extreme example.
Sure.
Let's say that you're running on GitHub and you didn't pay attention when you were building your code, and you wrote your secrets in plain text within your code.
Guilty.
And now, me too. A long time ago, I did it myself. Before I was more security savvy, I did it myself.
Yeah.
I'm betting a lot of starting out developers do the same thing. Just because it's easy. You write your code at home, you try it, and then you upload it to GitHub. You don't make sure to scrub your secrets first. Now that your secret is static and inside your code, anybody who has access to your code, let's say you made your repository public, which means anybody can look at your code, anybody can see that secret. Let's say that secret is your AWS key, which means anybody who can see that key, anybody can use it, and now they have access to your AWS resources. They can use them however they wish, and you will be paying up the bill for a long time to come. And paying the bill for somebody else using your S3 bucket, that's really small potatoes. You wouldn't really be worried about it. But just like somebody can take that AWS key and use your S3 bucket, a lot of really, really bad things could happen with some of those keys out there. So beyond scrubbing your code from any static secrets, using some sort of secret management and rotating your tokens and your keys and secrets and all that is a really good idea. It's not really connected to that chain of evidence, but we figured it was important enough and significant enough to include it in this webinar just as a starting off point. Now that we...
Well, I wanted to add one more thing to that. So the majority of the cloud providers today, the bigger ones like AWS, they actually have kind of their own policing of their keys. So they know what your keys are. So they do have like automated systems, and they're pretty good. I have to say, like this happens every now and then, where generally, it happens. You have a brain fart and boom, right? You release keys, but they will let you know. Like this has happened in the past. And by the way, this has been around for quite some time. Like AWS detects, hey, there's an exposed active key.
Yeah.
You might want to
change
it. They won't deactivate it because they don't know if it's intentional or whatever. But at the end of the day, they have the security teams. I have to give AWS props for that. It's happened multiple times where they even call the contacts who are in charge. But don't rely on that, right? Like that's just kind of giving you an example, and who knows if it works all the time. Right? So,
the fact that they needed to build a system for that just tells you how common it is.
Right. Well, so and I don't know if it's still true, but if it happens once, where you don't know it's happening and you get like a crazy bill, they're pretty good the first time, but don't let it happen again, right? Like they'll work with you. Put it that way.
So now let's get back into the let's call it the meat and potatoes of actual information inside that pipeline that we want to make sure happens as it should. And when we're talking about the pipeline and what's happening in it, the very first link is obviously that list of instructions. That's what makes the whole thing work. That's how you tell the pipeline what you want it to do. So verifying that that list of instructions is the same as you intended, that nobody messed with it or changed it, that's your first, let's call it, point of security. Because assuming somebody took over that list and changed it, they don't need anything else. It doesn't matter what other failsafes you have in place. If that list of instructions changed, they can do anything they want with your pipeline. Well, in this case, I will be the one providing a tool to verify this. It's a tool that I'll probably mention a few more times. Scribe, the company that I happen to work for, has a tool called Valid. It stands for Validation Integrity. One of its capabilities is to sign things cryptographically and then verify them. I'm not going to show you exactly how it works. You can go into our documentation and find that out very, very easily. And we're going to release a more powerful version of Valid very, very soon. But put in very, very basic terms, let's say you know exactly what that file is, which you should because you wrote it. You can sign it cryptographically using your identity, because you're inside, let's assume you're inside GitHub, you already signed in, so your identity is clear to GitHub. You sign it cryptographically. Every time you start the pipeline, you verify, again, using Valid, that that file, the file of instructions, is signed and using your particular signature. If that signature is not present or the file has changed, you have a problem. Making sure that the instruction file is safe and sound and secure is probably a good idea. And again, the Valid example is just an example of a tool to illustrate the point. You can use any other tool that you want, but making sure that the instruction file is untouched is a good idea regardless of the pipeline you're using. Because we have quite a few of these, I'm going to go to the next point unless anybody has a question.
I have some I can expand on that. So one of the kind of examples of this kind of pipeline hijacking, I guess, or pipeline configuration hijacking, right? Okay. So one of the things that I've seen a good example of this is in open source projects, right, where these like Surface AI, we give away a ton of free credits to open source projects. It's our way of kind of contributing to the community and helping developers and folks who are doing the Lord's work, so to speak, giving away software, building free software for everyone to use. But one of the examples of kind of this exploitation of these config files could be crypto miners, right? So that's one of the big ones where we've got compute available for people to use, but not the right people, or I shouldn't say not the right people, but the people are using it for the intent that wasn't intended, right? So that's kind of a good example of where, hey, if you have some measures, posturing in place to kind of understand and know when the config file has been compromised by someone outside of your organization, that's a good example, right? So, and obviously there's other telltale signs like, hey, why do I have a long-running job in my CI pipeline when usually it takes 10 minutes and it's been running for 48 minutes or 48 days, right? Like, oh, something's off, and it's usually what I've experienced is usually a crypto miner. Or maybe a DDoS attack, or coordinated, right? The DDoS attack. And so you're using compute in this case. So that's just one example of how like a tool like Scribe that you can sign and then verify that, hey, this is a legit file, and it's just your legit file. That's a layer of security that obviously, right? There's tons of ways to exploit things, but at least you have that layer of good feels, right? Yeah. So that was my little note on all that.
Our next point actually is more generalized because it deals with workflows. Now, the image that we showed, just for clarity's sake, was the lovely linear pipeline with sequential processes, one running after the other. But most pipelines are much more complicated than that. There's a lot of stuff going on. A lot of stuff usually happens in parallel. Some of the processes that happen in various workflows need to share resources between those different workflows. Now, usually workflows are independent because you don't want cross workflow contamination. But in cases where you need to share resources, there are various processes and methods and UIs and APIs in place. But the problem is that sharing those resources gives an opening for messing with those resources. Using dependencies, as a lot of programming languages do, and using a cache to store those dependencies, as is very, very economical to do, leaves an opening for something that is called cache poisoning, or dependency poisoning, or basically changing your dependencies.
Barak, before you go deeper into that, let's talk about why we cache, right? Because this is super important, and especially within the CI/CD or the continuous delivery realm. So obviously, right, you're using automation to do things consistently, reliably. And once you have those two kind of locked in and dialed in, you get efficiencies. And that means your velocity, your release velocity increases, but the quality should also increase, right? So these are the
There's also the reproducibility. If you're using everything exactly the same, that means that if you put in the same code, you should get the same result. And having reproducibility is a huge, important thing when you're dealing with software.
And that's where the consistency, right, comes in. So, having said that, when we're talking about the velocity, right? We in the software industry are competing against each other for the most part, right? And yeah, one of the main things we hear at Circle CI is, hey, I want my teams to be more like high performing, and which means you need to orchestrate your workloads as an engineering manager, right? Manage your developer resources more consistently. And without automation today, it's nearly impossible, right? To maintain, to achieve a certain velocity, reliable, consistent velocity, and then also go beyond that, right? Grow beyond that. So when we're talking about caching, that's a mechanism where, let's say you have Java developers, or this is notorious in Java, right? So you have huge dependencies and libraries, right, that you use in your code. Every time you pull that down from wherever, is it, Maven, whatever, right? Wherever the repository is for those libraries, it takes time, which slows down your pipeline, which extends, all these other things. That lowers your velocity. So the way to make these pipelines zing, I should say, and sing, I mean, who knows? But the way you make them zing is by having everything you download it once and then reusing that in a stored location. So like in Circle CI's case, we have a command within the pipeline definition called cache. And what it does is the first time this pipeline runs, it will check, do I have anything in this cache? Like, is there any? And if not, then boom, it starts to download. So the initial run of that pipeline will be quite longer than the subsequent ones, right? So what happens is then you restore that cache.
And it only downloads if there are changes.
Right. So when we're talking about cache, and I just want to level set folks who are not familiar, you never know. But with caching, obviously, right, you're storing stuff. And now we can talk about cache poisoning, which is we define what cache is, and now we can talk about it.
Yeah. So I've prepared this lovely little image. It says GitHub cache poisoning, but the same principles hold for Circle CI cache poisoning, or basically any other pipeline cache poisoning. You have this lovely little workflow on the top, and at the very beginning, we call a cache. Now, usually, if you think about a workflow, or let's even break it down further, let's say a piece of a workflow. You have something happens at the beginning, something happens in the middle, something happens at the end. Usually at the beginning, you do the check. Do I have a cache? If you don't, you download the information. At the end, you say, do I have a cache saved? If you don't, you save it. Very simple, very basic. But let's say somebody bad got into your pipeline, your workflow, something. And right before, you pull in the information as usual, right before you save it, they make a little change. They say, call in this version of this library. It's a slightly different version, it's fine. It's the same name. Hardly anybody would notice a third digit, past the dot, like 1.0.1 instead of 1.0.0.
Coming from a different location.
Obviously from a different location, same name. And now when we get to the end of, let's say, saving that cache, saves everything as normal, except that that one particular library has now been altered. Because it's in a cache, every subsequent workflow that says, do I have a cache? The answer would be, yes, you do. Okay, bring in the cache, use everything in it. So this particular form of attack doesn't just compromises your one workflow or your one pipeline run. Every other run of that pipeline that uses the same cache, continuously for however long it is, we keep using the same poison cache. So in the case that Angel gave us earlier, let's say that that modified package has a crypto miner or a backdoor, everything that's being built from here until that package changes would include the same backdoor or crypto miner in the final product. That is a lot of effect for such a tiny change. So once again, we're looking at a problem that requires the ability to make sure that whatever it is you're using, be it cache or another resource that is shared between workflows or dependencies, that whatever it is you're using is verifiable. And once again, I'll point your attention to Valent. Valent has the capability to sign not only files and images, it can also sign directories. So if you download in advance the dependencies that you know you need, or any other resource you know you need into a directory, you can sign the entire directory. Henceforth, you have a signed directory, which you can verify that it is indeed unchanged and signed. That's the whole point of signing. You know it's verifiable. Now that we've looked into that, basically we looked at a lot of things inside that pipeline, but because Angel gave my attention or directed my attention to the whole way in which a lot of pipelines are built, I've also made a point to ask you about parallel versus sequential. You made a point to say that when we're looking at caching or downloading things, it's important the order in which things are being operated within the pipeline. Would you like to elaborate on that?
Yeah. So what I meant, generally, like when we want our pipeline, so imagine, right? I'm a developer, I push some code.
Mhm.
I don't want to be staring and waiting at the Circle CI dashboard to tell me that my job is clean and green before I can move on, right? That's the whole point of the platform, is to address any failed builds or failed tests, whatever, right? So you want to, if there's a failure, you want to address it, right? Yeah. In order to speed that whole process up, along with caching, right? We have this concept of creating builds in parallel, right? Mm-hmm. Meaning, let's say you are going to, this is a good example, test 3 different versions, your application against 3 different versions of the Node.js library, right? Okay. Maybe you're using version 10, or I don't even know if that exists, I think so, but you're using version 10, you want to do a regression on 11, and then one maybe future on 12. Sort of an A/B test. Right. Instead of it going like, okay, do 11, then do 10, then 12, you can do all of them at the same time in parallel. Mm-hmm. Now, if you have a step with cache, right, enabled, and your cache is poisoned, it can all that cache is gonna be affected, right? So again, the point was, even if you do a sequential, same concept, but it's just gonna be a slower pipeline. But that's kind of I just wanted to address that as more like the impact of a polluted cache, right? A poison cache, it can affect all your pipeline runs, as well as maybe an external project. Maybe you have the libraries are centrally managed. It might be your own kind of version of your application. You pull that in. Maybe you build artifacts because it's a microservice, and you have the artifacts stored so that your pipelines can easily pull in binaries instead of building those things every time, right? If your cache for those binaries is already polluted or for that, right? It can it's just a kind of a chain effect, right? It can chain effect that can impact your whole organization.
I can also add that even though running things in parallel is a huge boost in efficiency, there are some things that running in sequentially could actually help. So let's say that you have tons of workflows, caching should probably be right along the start. So if you put that and then everything else runs in parallel, but you sign that initial step, then everything else can verify that. If, however, you run in parallel, that makes signing and verifying a little more complicated. So assuming you do want to do some sort of verification, not necessarily with signing, if you have a different way of doing it, doing at least the important bits first and then being able to verify them somehow later means that at least some parts of your pipeline should, at least in theory, be sequential so as not to widen the effect of any sort of breach in that pipeline.
Yeah, and maybe you don't have to do it every time, right, sequentially, but at a minimum, I would recommend maybe once a day, kind of a cron job. You can
Cleaning it up, yeah.
Well, do it running your tests on cache, right? Like you'll know if you have the original right signature. Maybe you do like a cron job where you test all your resources using whatever tool. But at the end of the day, right, you can, and then it's a separate pipeline, but you can flag things a lot easier and alert the appropriate people, maybe your CISOs or your security weenies or whatever in your organizations. But at the end of the day, as long as it's surfaced and people are aware, then you have a fighting chance of eliminating any kind of or minimizing the blast radius.
One of the things that we already mentioned earlier that is relevant to a lot of pipelines that can give almost unfettered access, assuming you have it, is SSH keys. Angel, would you like to tell us what they are and why they're potentially so dangerous?
Yeah, well, so I mean, obviously, right, SSH keys are basically your identity, right? And then you're creating these keys. It's your digital representation, right? Secure digital representation. So when you create these keys, you're obviously there's a pair, right? Mm-hmm. One is a public key, which that's the one you should be sharing with everyone, and then the private key, which is hosted on a system somewhere. And when you're sharing your public key with an integration, to maybe let's use a version control system like GitLab or something, right? You post your private key, and then they know they have that. So whenever your client uses the public key to try to access information, it knows, all right, this pairing is good. It chains up, it checks out. He's Angel Rivera. If I'm using
the resources that are
exactly. So with that though, obviously, right, it's usually one key per device. Could be a laptop, a phone, whatever.
Or a repository or account or GitHub account.
Exactly.
Stuff like that.
But if that private key is exposed to someone out that is not you, they can impersonate you, right? And basically log into any system where you have wired up that key pair. So that's basically in a nutshell what SSH is, but it's a secure access, right? So at the end of the day, usually port 22 if you're making requests. I would advise you not to use the default ports, but
makes sense.
But yeah, so SSH in a nutshell.
And the reason that we chose to mention those is because for convenience sake and because a lot of people work remote, it becomes sort of like an easy fix to create an SSH key linking you to your GitHub account, your pipeline, everything. Okay. So you can run those pipelines remotely, make sure everything is fine, you have access to the system, you can make changes, notifications to the YAML file, everything you need to do. Gives you remote access.
Yeah, basically. And the beauty of the SSH protocol is if you were to access your GitHub account, let's say for version control, using automation, guess what? It wants a password.
Yep.
So there's two options. Well, there's only one option. You hardwire your passwords in some value and then ship it on, or you use it. That's the other mechanism for SSH is to protect your identity without having to provide a password, right? So the idea is your machine or your devices are pretty much locked down to you, should be. So that means you don't need to enter a password, which is for automation purposes like Circle CI or whatever, running, jobs against your resources. That's one of the main reasons for the automation aspect of SSH, right? It's for automation to continue without having to, it minimizes the attack surface for you're not using a password is what I'm trying to say. It's not interactive, right? Where someone could be key logging you or whatever, right? Or your system even.
However, if you lose an SSH key or you build one up, use it to access your, let's say, GitHub, everything is hooked up, and somebody somehow gets access to that key, they cannot just impersonate you. They now have access, like Angel said, to everything you have access to. And in the case of your GitHub account, that access can do a lot of damage. So just like with secrets, make sure that you don't have any spare keys running around, rotate them, deactivate keys you no longer need or use, and make sure that your private keys are actually private and they haven't accidentally fallen into the wrong hands.
Oh, well, I know folks that have been using some SSH keys for like 10 years. So.
Wow, the same one? Wow, okay.
Yeah. Well, I mean, just recently these cloud providers started, changing the cipher. So like you are forced, and they start deprecating the old protocol, or the old cipher. So you're forced now
to rotate
more often. Yeah, because if you left to your own devices, come on, man, we leave. Yeah. Wow. It ain't broke. Why would I break it?
Yeah. Our next topic is actually, I think, the closest that you can get currently to a chain of evidence of what is actually happening within a pipeline. And to get more into that, Angel, why don't you tell our listeners, just in case they don't already know, what is salsa?
Good question.
Well, I mean, you're the guest.
Yeah, I mean, for me, it's basically, I guess, more of a specification, right, around. Honestly, I really don't have a lot of experience with it, so why don't you educate me? I'm willing to throw that at you. Thanks for the setup.
Hey,
I have a basic understanding, but I'd rather get educated by the master.
Sure. Salsa is the.
I know what salsa is. I make it at home all the time. So the cilantro, a little onion. No,
very tasty, especially with chips.
Digital.
And salsa is a new framework by Google built. It's essentially a checklist built for the purposes of improving security. There are several levels.
What does it stand for? Or what's the acronym and what's it stand for?
The acronym.
I'm sorry.
No, it's fine. It's fine. Supply chain levels for software artifacts.
Okay. That was Google? I didn't know that.
Yeah,
Nice.
it's created by Google.
Nice.
At least it's initiated by Google. The interesting thing about salsa is because it's backed by Google, it became pretty much synonymous with good practices.
Yeah.
But it's still in beta. There's no actual law or regulation that says you have to use salsa. But
so it hasn't been adopted, basically.
It's not officially adopted by anybody, but it's extremely well known by almost everybody in the security business. So when people are talking about supply chain security and security in general, for software, pipelines, and stuff like that, people always want to know: does it do salsa?
It's one of those.
Yeah, they don't necessarily.
It's an emerging standard.
Yeah, they don't even know necessarily what it is. They don't care what the little details are. They just want to have the star or check mark at the end. This is salsa verified. Now, salsa has several different levels. Level 1 being the easiest to achieve. Level 4 being nigh impossible to be able to prove. Salsa level 3 is pretty stringent, but it has a wide variety of requirements to show that your pipeline, your development process is indeed secure. Some very basic and common sense stuff like making sure that your developers have MFA and you sign commits, and that your pipeline is ephemeral and pulls stuff out of a machine. A lot of different rules and requirements. One of them that I want to mention in particular, because it revolves around those pipelines that we're talking about here, is the ability to show provenance. Now, provenance may mean a lot of different things to a lot of different people. I know that Steve Stringett, that I talked to in our previous webinar had his own opinion as to what it means, but for the salsa, the people who wrote the salsa checklist or standard, provenance means the origin, the place of origin of files. Now, if you want to be able to show that where actually files that got into the pipeline came from and where they ended up, if you think about it, that description or that log essentially tells you everything that happened inside the pipeline. The nice thing about the salsa, provenance file is that it doesn't actually look in your code. At least it's nice if you want your code to remain private and you don't want anybody to look at it. It doesn't look at your code. It doesn't care. All it does is look at files, hashes, stuff like that. It makes sure that whatever happened is recorded. Now, Scribe, again, company I happen to work for, has as part of its processes the ability to verify that a particular build in a particular pipeline is salsa compatible. As part of that, Scribe is enabling you to create a salsa provenance of everything that happened in my pipeline in that build. I'm going to share my screen just for a second, just to show you, just as an example, what it looks like. This is part of our documentation, as you can see. This is a segment of a provenance file. Assuming that you created that salsa provenance for your build, that provenance file will be, at least in theory, uploaded to Scribe. We keep it safe. You can also get a copy for yourself. You can do whatever you want with it, but looking inside, you will see a description pretty much like this. It shows you IDs, names, it shows you hashes of files. Essentially, if you break this JSON down, and I know it looks pretty incomprehensible if you just look at it for a second, but looking at the whole thing and knowing what the files are and what the pipeline is, you should be able to tell everything that happens, where the files came from, where they're going, that nothing was changed in the middle. Because obviously, if you have a file from the source going in, most of the time it shouldn't make any changes through the pipeline. Most of the time, some files need to be changed. If they're compiled, composited, integrated somehow.
The ones that really change are usually the config files, right? So that added value to make it
but
most to the server.
Most files
They shouldn't be changing.
modified. And so looking at the salsa provenance as some sort of log enables you in a pretty consistent way to make sure that nothing untoward happens within your pipeline.
So that's your basic, essentially your chain of custody that we're talking about, right? Like so, so that gives you pretty high visibility into what occurred in your pipeline, not just like in the Circle CI dashboard, complete successfully, right? Like you were saying earlier.
The interesting thing about a chain of custody is that it needs to be, let's say, unpolluted. Any tool that is designed to track something inside the pipeline that is under the control of the user could be theoretically tampered with. Okay. Having a machine-generated log like the salsa provenance created by the Scribe system of your build means that there's no way for any user to tamper with it. This is what happened. It just reported it. That's it. Nobody can change it.
The system generated, which is less likely to have.
Less likely. I'm sure it's
there's
possible
risk.
If somebody put their mind to it, but
there's always risk, right? Always. But at the end of the day, right, if you're getting a consistent chain there, right, being built.
So essentially, looking at an example of a product on our system, you'll be able to see the salsa provenance. We also check the Firmist SSDF compliance. But again, I'm not here to talk about Scribe. I mean, I have, but still. Just the idea of being able to track what is happening in your pipeline, however you choose to do this, that's what we're going for. And salsa provenance, however you choose to enact it on your pipeline, is one such way, with the added bonus that by enacting it, you could make your build salsa compliant. And I'm telling you, because I talk to a lot of people, even if they don't know what salsa is, telling them, yes, we are salsa compliant, would make them feel a lot better. They feel more secure just because you tell them you're salsa compliant.
Well, that's part of the whole thing, right? Like, so when you're building these, when folks are establishing, I should say, these kind of emerging standards, right? It's just like WC3, right? Like, come on, W3C, I should say. these standards, they change every 10 years, and I think that's getting actually
a lot faster.
A lot faster
Yeah.
because folks are realizing like we can't have nothing, right? We can't operate the same way. And yeah, this is great that like when I started out in this business, it was like it took 10 years.
It was a while ago, but don't mention
it's all good. It's all good. I'm okay. It's like almost 30 years, but at the end of the day, the advancements that I've seen over my career, and they're just getting faster and faster because we have to keep up. The humans are losing these battles to machines because once someone rigs up a nice hack, right, it's pretty much you're fighting computers, right? Like massive amounts of computers. And at the end of the day, these standards can help, if everyone follows them, help surface the ones who aren't following them, right? And that's kind of where I stand on all of this. And then
thank you for the best practice.
Yeah, thank you for the educational stuff. So I had a familiarity, but I didn't want to BS the crowd, right? It's not what we do.
I was just told that we had a question come in. Because we're really going a lot longer than I expected. I'll take it now. If you're treating your pipeline as code and securing the code repository, doesn't this secure your YAML? What are the benefits of using a separate tool for this? Angel?
I'm just digesting the question, so. So I see where you're going with this, Sean, but I think if you look at it the other way, what happens, you're securing your repository, but that doesn't mean someone can't access it post,
once the pipeline starts running.
Once the pipeline starts running, or even before it starts running, right? So like generally what will happen is if you have an intelligent or a competent attacker, they will figure out a way to change the code, like either right after your commit where your pipeline runs green, and then there's ways to do it at Circle CI. If you do a commit, and you can do like a follow-up commit, and you can tell just by putting in the commit message brackets skip CI bracket. Guess what? It won't build. Right. So if you're not paying, the system will show you, hey, there was a build that was skipped, a commit that was skipped. But if you're not paying attention, you've been hacked, right? And your build didn't happen. But when the next, you do a pull, and the next
will take the last.
Yeah. So to answer your question, Sean, yes, your YAML is secure in your repository, but if for some reason someone got phished and in your organization, and the attacker was able to get a commit in under your nose, which happens more often than you think, having that like a chain of custody type of execution will help, right? Like, hey, something's not right. Look this way, and then after this commit, subsequent commits are not, it's not looking the same.
Additionally, again, you need to think of the pipeline, or you don't need to. I suggest you think of the pipeline once it's running as its own unit. So your repository is secure, your code is secure, everything is fine. And just like our example earlier, all your secrets in that code are obfuscated. Nobody can see it. But once the pipeline starts running, obviously the secrets are exposed. Pipeline needs them. Everything is running. So if somebody gets into that pipeline, however they do it, maybe they have a backdoor into the tool that you're using for that pipeline. Maybe, I don't know. They got into the pipeline, they modify your instructions, everything runs, they modify it back, and nobody's the wiser. That's it. Your repository is still secure. It was secure before, it still is, but the pipeline wasn't running the way you intended it to. And unless you have some sort of in or log into that pipeline, you would never be able to tell, because everything you look at before and after look exactly the way you intended it to.
So I'll just give you an example. One of the easy ways to kind of accomplish this was, obviously I gave away a little bit of a hack, which I've actually done. But another way you
just
can
to test how to
exactly. And I never execute against my own repositories. But one of the other ways you can kind of get around this is by literally, the pipeline executes commands. So if you have a wget command it's just a simple wget that kicks off a
Something
service
else,
and
yeah.
you have access to that runtime in the pipeline environment, you can extrapolate sensitive secrets, right?
Yeah,
And then
mhm.
transmit them to a service that can then, on your behalf, execute
Something
in
else.
from some other cloud, and then there's a whole vicious cycle. So yeah, there's a lot of exploitations I could go through. I could give tons of examples, but I won't do that today. But
Yeah,
we're
we're
running
almost
out of time. But yeah, but to answer your question, it was Sean, I think. Yeah, there's yes, you are protected, but to a degree, just like anything else, right? It's just like you have an alarm in your home, maybe alarm system, cameras everywhere, but that doesn't stop anyone from putting a laser pointer in it and then having another attacker break a window and in and out, right? Like it's sorry, I'm giving away way too many. It's my background.
People might think you're a career criminal.
Yeah, well,
Okay, so one last thing before we sign off. I know we're running a little longer than intended, but this one is important, so I really don't want to sign off before going over it. Let's take a look at that pipeline slide, the initial one more time, and we'll look right at the end of it because this is the end of the pipeline. So we built the image and we're ready for deployment. We're ready to upload it to wherever we host our images or our binaries or something. And we're done, right? Everything's fine. We protected our pipeline. We know exactly what happened in it. Everything's great. Except that no matter what defenses we have in place, let's say somebody got in right at the end there, right at the end. We built our image, we tested it, everything is fine. But right before we upload it, they substitute their own image. It looks almost exactly the same. And if we employ signing right before we upload, then they can even sign it because they're inside our pipeline. And whenever somebody goes to download our product or image, it's the bad guy's image. And nobody would be any wiser. The only way around that is to sign your image as soon as you build it. Don't wait. Just as soon as it's done, sign it. And make sure that the version that you're uploading is also signed, so that anybody who wants to access it can verify that signature. Unless you do that, you run the risk of a very, very popular or infamous hack, which I'm sure you know is SolarWinds. All they did was modify a few lines. Everything was uploaded as planned. Everything was signed properly. Everybody was using it without a problem. So, yeah.
We can thank them for the emphasis on S-bombs, right? Like that was in a serious sense. Everyone, everyone has a turn in the barrel, so to speak, when it comes to security incidents. And unfortunate for them, obviously they didn't intend it. But one of the things that I would recommend on top of, build, sign, but then also validate after deployment, right? So validate before, so sign, then before deploy, validate, and then after validate. Because there are tricks you can do to,
a mirror site that looks almost exactly like yours. It just takes it from somewhere else.
Right. So there's a lot of layers to it, but it doesn't hurt to be a little more redundant on the important parts, because once you activate that polluted or contaminated image, it's a lot harder to bring that back in, right?
Yeah.
Especially if you're
once it's out in the world.
Yeah. Well, I mean, think about it, right? We're talking the age of Kubernetes, right? So we're talking about big clusters of systems, right? That takes one image and just propagates it everywhere. If you have tens of thousands of these pods and images, containers running with the contaminated image, you have tens of thousands of contaminated images systems, right, to deal with.
So just to to catch everybody in and sum up before we'll sign off, and apologize for taking longer than expected.
They love it. Don't worry about it. They never apologize.
So we're looking at this pipeline, right? We're talking about different elements. The elements that we suggested you concentrate on with whatever tools you want. Make sure you use some sort of secret management and that your secrets are not exposed. Rotate them frequently. Verify the integrity of your pipeline instruction file. However that instruction file is constructed, wherever it is, make sure that you're using always the one that you've verified that you constructed and not somebody else substituted it for. Make sure that whatever resources are shared between workflows, be it the cache, be it download dependencies or any other stuff that is being built or used throughout the workflows is always verify that nobody made any changes to whatever it is you're downloading, caching, your dependencies, or anything else that is being shared between workflows. Make sure you don't use any SS keys that are not properly secured, that you don't have SSH keys running around that you're not using that could be accessed by somebody else. As a theory or as a possibility of creating a log for whatever happens in your pipeline, we suggested using salsa provenance, creating a salsa provenance for your build, your pipeline. It's a great log of everything that goes in and out. And beware of hijacking of a final image. So we offered to sign it, validate it right before you upload it to wherever it needs to go, and right before somebody downloads it to be used. That's basically.
And post-deployment.
And obviously.
If you can.
Everywhere.
Yes.
Verified everywhere.
Yeah.
So yeah, that's our at least initial thinking. I'm sure we have a lot more to say about a lot of different parts and elements of the pipeline, but this is our crash course on how to make whatever pipeline you're using more secure. We have one more question. So
yeah,
before
let's do
we,
it. The
before
questions
we sign out,
they're maintained.
Yeah, Mark, you came in right in the nick of time. So, isn't the post-deployment signature validation a FIM? Do you know what a FIM is? I don't remember.
I'm not familiar. I'm sure it's the information management or something.
Let's check what FIM is.
Let's look it up.
Because, that's why we have Google here.
Yeah.
Functional independence measure. Not sure what that is, but
let's say
whose responsibility is
it? I would say whoever is maintaining the observability metrics or the system. I don't want to throw operators under the bus here, but it could be.
File integrity management.
There you
go. Mark.
Yeah. Sorry.
Yeah.
So I mean, I don't care what the role name is. Whoever is in charge of post-deployment operations, I've actually heard of file integrity, so I know. But at the end of the day, right? If you're talking about a human or a role, fine, file integrity manager. If it's an automated system, yeah, sure. Yeah. That's even better, right? You can just wire up a Valence and do it. But at the end of the day, the role shouldn't matter, but the actual execution of that post validation should be done.
I would like to add whatever the role or the system that checks it, don't fall into the trap of saying it's not my problem, it's somebody else's problem, somebody else's responsibility. I know that it could be a problem in larger organizations where there are departments and politics, and you might want somebody else to fail, so you could say, aha, I told you so, I warned you, you didn't listen. But we're all here for everybody else's security, and one such problem, like Angel described so vividly a few minutes ago, one such bad image out in the world could be disastrous, a gigantic blast radius that you can't even grasp with the way software is being disseminated these days. So however you choose to do this, whatever process your company, whoever decides to implement, whichever person or system needs to do it, we still recommend, however you choose to do it, that you verify that whatever image or file or artifact was created by your pipeline is actually the one that you're deploying or using for your clients, your system, whatever it is you're doing with it. Because again, we're trying to be general here. Making sure that whatever you created was actually the thing that you're using is important because...
and I'll also add one more thing before, I know we're going over and over, but you can use feature flagging type tooling, right, to implement that as well. So like canary deployments, right? You can throw your whatever percentage of your users, make the changes go to them.
It's called a smoke screen.
Smoke test, right? That's exactly right. I have a talk on this I give all the time, but at the end of the day, you just want to do a quick validation post deployment, and then from there, you have automated checks. Boom, give it to 10%. Give it to follow your.
There are various
deployment.
ways to do this. Lots of different methods. We're not here to tell you.
But again,
use this.
Automate it if you can.
Automate it if you can. It's true for everything we say on this topic.
For the most part.
So we're over an hour long.
It's
pretty much time for us to say bye. I would like to thank Angel for joining me today. I would like to thank all of you for joining us, listening, bringing your questions in. This webinar is going to go online pretty much as soon as we're done. It's going to be both here on LinkedIn and eventually on YouTube. If you have any other questions about the tools we mentioned, about other processes or stuff that you should or should not be protecting your pipeline, feel free to drop a line with the Scribe and myself here or Angel. I'm sure we'll be happy to answer. Our purpose here is not to convince you to use our tool or a different tool or a different system. It's to make you more secure for the betterment of all of us. So with that in mind, be safe, be secure, and see you in our next webinar. Bye.
Thank you.